particles to this ground level, we have to modify these particular parameters on the surface of the material. So those parameters will enhance the settling rate of the contaminants which is present in this wastewater system. The contaminants might be soluble or might be insoluble or might be there be a microbial species, whatever it is. So, but we have to consider all these four parameters. So, based upon these four parameters, we can play to do this research to develop the material for the sedimentation or for this settlement of the particle. So generally, we are using a lot of chemical methods for the settlement of these all waste particles like coagulation, flocculation, agglomerations, sedimentation process. But in all this process, adsorption is one of the basic physiochemical study or physiochemical interactions involved for the separation of this waste material. Okay. At the same time, next in my result, I'll discuss how this adsorption takes place. And also, the another important parameters based upon the specific gravity also, the level of the liquid effluents will be differed in this place of the wastewater. For an example, if you take this oil, which is having very less specific gravity than water. So because of that reason, once the water is contaminated by the oil, it is always present on the surface of the water, not in this beneath of the water. So based upon the specific gravity of the parameter of the liquid effluent, so the place where it is present will be differed. At the same time, if you see there's a trichloroethylene on the other hand, which is highly heavier than the water. So because of the reason, it will be sink inside of the water and it will called as a dense non-aqueous phase liquid. So based upon this density or based upon the specific gravity of the liquid effluent which is placed or which is present on the surface or otherwise the beneath of the water will be what differed. So specific gravity is also another important factor we have to think when you are trying to remediate this liquid or when you are trying to remove this liquid effluent. And sometimes when you're talking about the pesticide removals, the pesticides are generally are highly soluble nature in this water. And also if you want to remove or if it is naturally if it wants to remove on the surface of the land surface, if the pH has to be increased. At the same time, the temperature has to be increased, and it requires very less moisture conditions, and also it needs a huge amount of oxygen for the oxidation process for the breakdown of this compounds. So these are all the factors that we have to be considered before we have to start to develop this uh, biomaterial or any material for this removal of this waste matters. And generally, these pollutants will be classified into two types. One is this organic pollutant, and the other one is the inorganic pollutant. At the same time, some organic pollutants we can degrade, and some of the organic pollutants we can't able to degrade. That we are saying this non-degrading organic pollutants. So the degradation process, generally this organic contaminant degradation process will be carried out by two different processes. One is this enzymatic degradation and other one is the chemical process with the help of hydrolysis and this oxidation and reduction process. When you're coming for this non-degradation process, this these toxic components will be converted into a non-toxic form by this breakdowns of the for the breakdown of the complex molecule into simpler molecules with the usage of the physiochemical parameters. And also we can carry out the process with the help of the adsorption process. The adsorption process is nothing but it is a surface of phenomena which is interaction between this solid and this liquid phase. Now we have to think about how the solid has particle has to be developed for the removal of what this toxic contaminants. And another contaminants we are saying that inorganic pollutants, it is generally not degradable in nature. If you take a metal solution, even for 100 years, the metal solutions will not be what get degraded. It might be converted into hydroxide form or otherwise it might be there as such in this oxidation state. So we can degrade those molecules or those compounds with the help of this transforming the oxidation state or transforming from this by this electron transfer and also by the surface adsorption process. And also we can precipitate the molecule by the addition of the alkali compounds, and also with the help of the solvents we can able to do this phase separation process. So what are the different processes or what are the different ways we can carry out these two processes? The process of a treatment can be generally separated, differentiated into two different ways. One is aerobically also we can perform, and also anaerobically we can also perform. So when you are carried out the process in aerobic conditions, most of the process we are carried out in this open system in this industry. Why? Because then only we can maintain the process at a constant pressure and this constant temperature conditions. But when you are when you are carried out the process in a closed system, we can maintain the constant temperature. Sometimes the temperature will be uh, changed because of the formation of gas. Those gases can able to increase the kinetic energy in this inside the system. Because of the reason, sometimes temperature might increase, but the pressure will be varied in a closed system. And even if you're coming to this anaerobic process, the constant temperature might be there, and sometimes temperature might be varied, but very importantly, the pressure will be varied during this process. At the same time, we have to think about another different parameter is natural convection and post convection. Whenever we are trying to synthesize the material, whether it will be get settled or not, we have to know that. If suppose if you are synthesizing a nanomaterial, if the nanomaterial that's acting as an adsorbent, if the nanomaterial settles very quickly, then we have to give a huge amount of force, or we have to give a huge amount of energy to maintain its dispersing state. So it is very important to study about the mass transfer operation, whether we can able to do the process by the natural convection process or by this post convection process. So with the help of these two processes, thermodynamically, we have to understand that whether this process is thermodynamically favorable, and also if the mass transfer process, how we have to be carried out, whether we can carry it out by the natural convection or by this forced convection. Why? Because these two processes only decided the economy of the process of this wastewater treatment. Why? Because generally whenever we are working on industry people knows that up to this reaction part, up to the source of the reaction part, the amount whatever we are spending, the money whatever is spending is somewhat comparatively twofold lesser than that of what we are using in the downstream processing process. So we have to know that. So we have to think about these different field of science for the implementations of wastewater treatment. And what is the purpose of developing this biomaterial? So for an example, if you take any organic compound or any polymeric substance, it has its own half-life period. If as such, if you leave that within 3 years or within 4 years, it automatically degrades itself. Am I right? At the same time, the purpose of developing this kind of biomaterials, we are trying to increase the rate of the reaction. We don't want to wait till its half-life period. So whenever we are doing any kind of a process or the removal of any organic compound, first of all, we have to know about this. What is the half-life period of this particular compound? So if the half-life period of any organic or any contaminant is very less, then there is no need of developing any material for a degrade those compounds. If suppose if it is very, it takes more 5 days or 10 days or 1 year or 1 month half-life period is there more than 10 years or 100 years, then as a researcher, we have to try to develop a biomaterial or any material for this removal of this particular waste thing. And also when you're talking about the removal of the metal ions, the main reason of the developing of materials is if you see any natural material or the any chemical method, we always try to precipitate that. But instead of precipitating, we are following some adsorption process with the help of the interaction between the metal ion along with this some functional groups. If the functional group is very less, the interaction between the metal ions along with this ligands will be decreased. So by increasing the active sites, we can increase the interaction effect. That's why that is the main reason we are trying to improve or we are trying to improve the develop this modified material for the purpose of increasing the rate of reactions and also increasing the active sites. These are all the major 2 points, the reason of developing the biomaterial or the new synthetic material for this process. So for this, for the removal of this particular metal ions in the wastewater, I have some results. So we done some research on the usage of bacteria for the removal of heavy metals, not only bacteria and its proteins, protein materials we are using for the same removal of wastewater. Now I would like to compare the results of the adsorption effect of bacteria, the biomaterial, and the removal of the same heavy metal with the help of this protein molecules. So from that we can compare this. So what is the efficiency or what is the advantage of developing or modifying or otherwise a new synthesis, new synthetic biomaterial we can observe from this result. So generally, we are carried out the wastewater treatment by three conventional methods like chemical precipitation, coagulation, ion exchange, solvent extraction, evaporation, and the membrane process. We know very well about this. But these processes are all having a particular disadvantages. Some process will be produces the secondary metabolites or secondary sludges. Some process will be give some toxic effect inside the solution. So because of that, all these reasons, we are trying to move towards this an alternative method, which is tell it as biosorption or bioremediation. In that bioremediation, the interaction generally takes place between two materials. One is solute and another one is the sorbate material, which is solid material, which is mainly used for the interaction purpose. So the solute is always present in the liquid. We are saying that heavy metals, whatever the contaminant, what is present there. And the sorbate is a represent what is the solid material which is going to interact on the surface. Here in this topic, I would like to share some knowledge of how this bacteria will be interact with the metal ions on the surface of this microorganism. Before that, I want to give some basic information about that, how it will be interacted on the surface of the bacteria, why it is interacted on the surface of the bacteria. First, we should know that generally based upon the structural information of the bacteria will be classified into two types. One is gram-positive bacteria and other one is the gram-negative bacteria. The cell wall of the gram-positive bacteria mainly consisting of three different components such as the cytoplasm, peptidoglycan, and teichoic acid. And the cell walls is also constituted with this cytoplasm, which is bind to the peptidoglycan, which in turns and covalently bounded with this teichoic acids. These teichoic acid use a overall negative charge on the gram-positive cell due to the presence of a phosphodiester bonds between the teichoic acid monomers. That is the very important point we have to note it down. Why? Because here we are going to carry out our interaction based upon the surface charge which is involved here actually. Okay, that's why I'm insisting that what is the surface charge which is present on the gram-positive bacteria and which material which exposes or which acid exposes the negative surface charge on the surface of the bacteria. And then the peptidoglycan layer and the teichoic acid or the teichoic acid are the major anionic functional groups present on the surface of the gram-positive bacteria. When you are coming to this gram-negative bacteria, this gram-negative bacteria morphology is totally different. It has a lipopolysaccharides on the surface of the bacteria, and also it has the lipid molecules, core polysaccharide, and more specific antigens in this part of this polysaccharide, lipopolysaccharides. These materials, which is mainly consisting of fatty acids, sugars, and phosphate groups, and also it might have phospholipids and the liposaccharides. These molecules or these fatty acids or sugars or phosphate groups, function groups having the property to expose us a negative surface charge with respect to the pH conditions. So when we are designing any biomaterial, the functional groups, whatever it is present on the surface of the material, so the surface charge will be varied with respect to the pH of the system. Why? Because most of the wastewater or contaminants will be removed with the help of a degradation process as well as by the physiochemical interactions. So here these adsorption process are all comes under the physiochemical interactions between the surface of the sorbate and this sorbent level. Okay, what are the different mechanism which is mainly involving on the surface adsorption? One is the ion exchange process. It is the interaction takes place by the exchanging of ions. And other one is the electrostatic interactions. This electrostatic interaction is nothing but there is an interaction between the surface and the solute, and also that electrostatic interactions and some other chemical interactions also carried out by the complexation, coordination process, and also some of the process which might be carried out by the precipitation, that is the metal precipitations. Metal precipitation is nothing but some kind of a protein molecules will be produced during the growth of the microorganism. Those products will alter the pH of the system. Because of the changing of the pH of the system, the metal will get precipitate. And some of the biomaterials will accumulate those kind of metal ions to survive in this environment. So these are all the different two processes involved here. One is the sorption process and other one is the accumulation process. The sorption process, it is generally a non-metabolic dependent process, and the accumulation process is a metabolic dependent process. This metabolic process only we can carry it out in this live cell, and also and particularly this non-metabolic dependent, we can carry it out both on the live cell as well as the dead cells also. We can carry it out this process particularly. Okay. Next, I want to tell some results in this part. So first of all, when you are starting or when you are trying to remove any wastewater, we should know that what is the characteristic of wastewater. If suppose if the wastewater consisting of a lot of precipitates, it will not present on the surface of the water. Most of the time, it will be settled, or otherwise it will be in the form of a suspended solids. So it is very important to system how a particle, how a wastewater will be behaved with respect to the pH of these conditions. Here I worked on particularly on zinc. Here it clearly stated that how the particular zinc molecules will be characterized or will be exposes its species with respect to the pH conditions. So from this graph, we can observe that till P5 pH, the concentration of the zinc is remains same. It clearly stated that that particular metal ion is highly soluble species in this water aquatic system. And further increasing the pH of the system, the concentration of the zinc ion is totally get reduced because of the formation of the precipitate. So because of the formation of the hydroxide form, it will be try to the concentration is getting down, and further increasing the pH, the concentration of the zinc is increased because of the formation of negative anionic species. So whenever we are talking with respect to the pH of the system, the wastewater what we are trying to remediate will be changed according to the species of the wastewater will be changed according to the pH of the system. At the same time, the solute surface charge, the sorbate surface charge also what get changed, that we will discuss later now. And this is the result. Here we can observe that when I'm changing that, if I'm not adding any biosorbent, and after adding the biosorbent material, how the interactions will be takes place. I already told that this bacterial surface is consisting of a different functional group like carboxyl, phosphate, amines. These particular materials, which is this particular functional group, is mainly responsible of the what removal of heavy metals. So even whenever designing any kind of biomaterial also, we have to think about that what are the functional groups we have to develop on the surface of it. That functional group should have the surface should have the functional groups of carboxyl, phosphate, amines, and hydroxyls, which is responsible for the interaction of what with metal ions. So in this process, or in this result, we can observe that in the absence of a biomaterial or in the absence of a bacteria, there is no interaction which takes place. The metal ion is highly stable. Why? Because there is no change in the concentration of the zinc. And further adding the biosorbent with respect to the pH conditions, the interaction between this biomaterial on the metal ions will be get increased. Why? Because when the pH increases, the carboxyl group or this hydroxyl group or this phosphate group will be started to get deprotonated and exposes a negative surface charge. So because of the exposing of the negative surface charge, the positive cationic metal will be interacted on the surface of the bacteria, then the interactions will be increased. So from this condition, we can optimally say that at a 5 pH of the system, the interactions will be more. And very important thing is whenever we are performing this experiment, we are giving some external energy. But whenever we are using in this industrial process, it is very difficult to do the process by using what a forced convection. So we have to think about that we have to use some external energy to develop the material. So to develop the material, it should not be what it should follow this natural convection process. Then only we can reduce this, the usage of the power sources or the electrical sources. And here in this study, I compared these two results. One is based upon this removal of the particular metal with the help of the biosorbent, and other one is the metabolite, the protein molecules, how it is behaving for the removal of this particular metal. Why? Because these protein molecules also consisting of a comprised with the carboxyl group, phosphate group, amine group only. So because of the presence of the same functional group, the characteristics or the interaction property will be more or less same, more or less same. But how much amount of metal ion is include or removed? That is the very big question here. So from this, when I'm increasing the cell number from the 10 power 9 to the 10 power 11 magnitude, the maximum amount of zinc will be removed around 60 percentage. This unit you can see that mg of zinc biosoft per cell, or otherwise we can tell it as, if you take it weigh it, we can always tell it in terms of grams. So per grams, the next graph, the result is there. So based upon this per cell, it will be what calculated, it is achieved 60%. But coming to this graph, in this y-axis, we can say that per milligram of a protein, I can able to increase the absorption effect amount of zinc biosorbed mg. In terms of mg, I'm representing here. It is around how much? It is maximum around 16 milligram of a biosorbed in the presence of what per milligram of protein. And if you here, if you see that amount of zinc absorbed, it is around 10 power minus 10 milligram of zinc will be absorbed per unit cell. So from the comparative of this particular native biosorbent as well as the protein molecule, if you increases the active sites, if you increases the active sites, the interaction efficiency also be increased. So far, whatever I discussed, I told that one is based upon the surface charge and based upon the pH of the system and based upon the increasing of the active sites, the interactions will be what can be able to develop that. And if you coming to this study, this process, this result will be compared by varying the metal concentration, how it will be behaved. So in this graph, we can clearly stated that the maximum amount of zinc per gram of dry cells, it is around 11 gram of thing for by the bacteria. And if you are coming to this system, the nearly around the maximum 16 milligram of zinc will be biosorbed per milligram of protein. So it is 1,000 times greater than that of the plus. Why? Because here it is gram per dry cells, and here you can see that a milligram of a protein. So the size of the protein and the functional groups of the protein, so and the pKs of the system, as well as as well as yeah, stability of these molecules will plays a big role in this removal of what the particular wastewater treatment. So whenever we are trying to design any kind of a adsorbent material, we have to think about these properties for this process, for this wastewater treatment process. And here, the major functional group present in both the native species as well as in the protein molecule, it will be confirmed. What are this? By comparing these two results, we can observe that most of the time or most of the functional groups is remain same in both these protein molecules as well as in this bacterial molecules. So we can observe this FTR shape or FTR functional groups or amine and primary amine along with hydroxyl group, amide 1 with carboxyl group, amide 2 in this NH bend and this CH stretching, and we are having the carboxyl group and phosphate group, whether it is asymmetric stretching, and the other one is what phosphate group is symmetric stretching. And here also we can observe that the same kind of function group in the extracellular protein secreted by the bacteria. So from this result, we can, it clearly says that actually, so once the functional group is remains same, the characteristic of interaction is also same. But when you are increasing the number of active sites, the adsorption effect will be increased. Okay, and this result is explains about the redox spectrogram. In this bacteria, we can observe that the carbon, oxygen, phosphate, and sulfur group. And after interaction, we can observe that it have the capability of interaction very less amount of a concentration. But when we are trying to synthesize or when we isolate the protein molecules, the protein molecules can able to remove huge amount of zinc metals from this waste water because of the presence of huge amount of what active sites or huge amount of active sites present on the a huge amount of functional groups present on this protein molecules. And very important study, this is very important study whenever we are studying any kind of a coagulation process as well as any kind of adsorption process. So by measuring the zeta potential, we can able to confirm whether the interaction is takes place or not. It's very important study actually. So this particular lower graph which explains that what is the negative negative potential or negative surface charge existed on the surface of the surface of the bacteria due to the presence of the functional groups. So with respect to changing the pH of the system, the surface charge will be what get varied from positive to the negative, where there is a point which converts from positive, shift from the positive to the negative. That point we are saying that isoelectric point. So each and every bacteria have its own isoelectric point. Why? Because the functional group which is present on the surface of the bacteria will not be same for all the species. So after interactions, we can observe that there is a reduction of a negative surface charge. So from this in the values, we can able to tell that how the interactions or whether the interactions takes place or not. So even in the coagulation process, even in the flocculation process, even in the settling process, it is very important to evaluate the zeta potential studies between the wastewater contaminants and the sorbent material what we are going to use in this. Okay, so with this, I come to a conclusion that whenever we are talking about a biomaterial, it should not be toxic to the environment. And also, what are the physiochemical parameters we have to be considered for this development of a particular biomaterial, like pH of the pH or otherwise the surface charge and the particle size plays a big role, and the surface charge will be plays a big role for the removal of wastewater. And next process is the coagulation and flocculation process. This is one of the very best or very one of the very largest application method in most of the industries. And this particular coagulation and flocculation process nowadays they are doing the consecutively or simultaneously. And now because of the development of the science and the research, now we are carried out a direct flocculation process with the help of some material development process or by using some grafting process or by using some modified process. Nowadays, we are doing the process or we are trying to remove the waste material with this direct flocculation process. Generally, what are the different processes we can use in this wastewater treatment? One is this coagulation and flocculation for the removal of a solid material and also for the water clarification, drinking water treatment, decontamination of wastewater, solid dewatering process, sludge thickening process, and the slime softening process. These are all the major processes we are used for this coagulation and this flocculation process. And the treatment of process we can carry it out by combination of both coagulation as well as the flocculation. So when we are doing the coagulation process, it try to neutralize the charge and it brings the colloidal particles nearer to each other. After that, with the help of these polymeric compounds, we are trying to flocculate the waste materials and try to settle down. That is the general mechanism whichever we are carried out or we just observed during the time of this coagulation and this flocculation process. So this is the two different process when we are carried out this uh, uh, carried out both coagulation and flocculation. In the coagulation process, we are trying to destabilize the surface, thus negative surface charge molecule. After destabilize, we are trying to aggregate the molecule with the help of this polymeric compounds. What are the different components? For an example, solids and colloids, dissolved organic matters, organic and inorganic matters, the microorganism which is present on there. So all and also some of the phosphate, oils, colors, odors, or dye components or protein molecules. All these components we can remove or we can settle. The very important point is we can settle by changing the surface charge of the particular molecule with the help of this coagulants and the flocculants. Okay, so from this schematic representation, we can clearly observe that first initially the wastewater, first we are adding the coagulant in the wastewater. This, generally we are adding metal salts. For an example of aluminum chloride, we are adding into this Al3 plus will be the positive surface metal ion will try to neutralize the negative surface charge material which is present on that. After once if it is started to neutralize that, this electrostatic interaction helps to try to bind the particles on the surface of the coagulants. So based after we try to interactions that these particles are try to settle down and comes nearer. So once if you're adding the polymeric compound like this flocculant, so it will makes the flocks and it will be interacted together. Finally, it will be try to settle down. So with this help of this flocculant process, we can able to do this process. What are the different types of coagulation? What is the mechanism generally involved in this process? One is the charge neutralization process, And other one is this another coagulation process is sweep coagulation process. So these are the major different types of coagulation process. They are carried out with this help of this material. And other one is the flocculant, which is two mechanisms involved by the flocculants. One is the bridging process, and other one is the patch flocculation process. How this mechanism, general mechanism, will be happened, which we clearly explained in this surface charge, how the surface charges takes place here with the help of the electrical double theory. So we can observe that you consider this is the particle surface charge. Once if you added the positive ions, nothing but this metallic salts, this particular positive ions will be go and interacted or electrostatically interacted on the surface of the negative surface charge. This layer is very high strong layer or strong interaction layer. It is very difficult to remove from this two surface. So that particular layer we have called it as a stain potential or stain layer, we can say that. So some other layers or some of our other molecules which is try to move towards this particular layer. So after at a particular layer, there is no interactions or the flow of the electromobility of those particular ions will be huge here. The flow of ions will be huge here. So there is a electrophoretic mobility between this thin layer and this diffuse layer. We can say that sometimes we can say that it is the double layer. Sometimes we can say that it's a diffuse layer. Up to this, we can say that here the rate of diffusion or the rate of zeta potential, the value of zeta potential is zero. So once if you want to measure the changes in the potential between this thin layer and the diffuse layer, that layer we can say it is actually strain potential, zeta potential layer, or otherwise we can measure the zeta potential at this point only. But generally we can't able to measure the zeta potential directly. We can measure the zeta potential based on this electrophoretic mobility of this particular solute between this solutes and the sorbents, or the sorbent as the sorbates. So based upon the zeta potential, we can explain the efficiency of the interaction of any coagulant or any flocculant. If suppose we are developing any coagulant or any flocculant for the removal of any wastewater, this particular study is very important to explain the characteristic of the interaction efficiency. So if there is no change in the zeta potential value, it clearly stated that there is no interaction which takes place. And based upon the surface charge of the particle, we can decide that what type of material we want to remove. Suppose if the surface charge exposes a negative surface charge, then we can decide that, okay, we can remove the positive surface charge wastewater electrostatically. If suppose the material which exposes the highly positive surface charge, then we can use it for the removal of negative surface charge particle, whether it may be a microorganism, whether it may be any contaminants which exposes the negative surface charge. And generally, these coagulants will be classified into two types. One is the inorganic based product, and other one is the organic based products. This inorganic based products, most of the time we are using this metal salts for the improving the coagulation efficiency. Based upon this mineral additives, we are using lime, calcium salt, magnesium carbonate. When you are coming for the hydrolyzing the metal salts, we are using the aluminum sulfate, ferric chloride, ferric sulfate, and sodium aluminate. When you are coming for this pre-hydrolyzed metals, we are using polyaluminum chloride, polyalumino-silicate sulfate, polyferric sulfate. At the same time, some kind of organic based materials we are using, we are saying it is polyelectrolytes, which is having this surface charge, both the positive as well as this negative. And other one is for this flocculant process, to flock the molecules, we are using flocculants also. That flocculants will be categorized into this inorganic based polymeric flocculant, and also for organic based product flocculants. This this inorganic molecules, inorganic types are pre-hydrolyzed polyelectrolyte like polyaluminum chloride or polyferric sulfate, and you are coming to this polymeric organic based, it will be classified into cationic polyelectrolytes, anionic polyelectrolytes, and sometimes it will call it as non-ionic polymers. This classification, it is mainly depends upon the exposing of the surface charge of the polymeric compounds. If the polymeric compounds exposes a positive surface charge, then we can say that it is a cationic polyelectrolytes. Some polymeric compounds which exposes a negative surface charge, we are saying it is an anionic polyelectrolytes. If it is not exposing any charge or equally it is neutralized, then we can say it as non-ionic surface charge. Generally, in this talk, I am going to discuss about four different natural polymers, which is mainly used for this treatment process. One is the guar gum, starch, chitosan, and cellulosic material. This guar gum, when you're talking about this guar gum, generally guar gum is a non-ionic compound. It's a polysaccharide, and you can extracted this particular guar gum from the endosperm of the seeds, and it is having naturally a biocompatible material, and it mainly consists of 1 comma 4 linkage of 1 comma 4 linkage of mannose spermatozoil, and also it is having the 1 comma 6 linkage of a galactose in it. And the very important thing is here only, this is the very important part in this big polymeric molecule. Why? Because if you want to modify active sites on the surface of the guar gum, you can play with this hydrogen ions which is present in that with respect to the pH conditions. And if you remove that by using any free radical process, then you can attach or you can modify the particular guar gum by the cationic guar gum, or otherwise we can convert it into this anionic guar gum. But most of the time we are trying to use the ammonium sulfate to develop this cationic surface charge guar gum. So now next slide we'll see that actually. So from this schematic representations, we know that this particular polysaccharides will have these ionizable groups also. This ionizable group, whatever we're talking, which is mainly depends upon the removal of H plus ions on the surface. And also it has both macromolecules as well as these micromolecules. These micromolecules will be entered into this solution, and these macromolecules will be remain as such. So with respect to the pH of the conditions, the functional group, whatever the hydroxyl group, whatever it is present on the surface of the material, will try to expose or changing the surface charge of the particular guar gum. If you want to develop a cationic guar gum, we can use the quaternary ammonium molecules or ammonium ions for the development of what's the particular cationic surface charge. So from the zeta potential graph, we can clearly observe that the guar gum, the general guar gum, which is having a negative surface charge, when the pH was changed from 2 to 8, you can see that it's clearly stated that the surface charge of the guar gum having a negative surface charge from the in the range of -5 to -540. So when you want to use for the removal of wastewater, that wastewater should have a positive surface charge wastewater material. Then it is selectively increases the adsorption effect. Why? Because this particular guar gum at that pH condition, it has what? A high negative surface charge. When it is modified with the help of the ammonium sulfate or ammonium ions, the NH4 molecules, or which is tried to, or NH3 molecules, which is tried to develop a cationic surface charge on the surface of the guar gum. So because of the changing of the surface charge of the particular guar gum, it can expose as a positive surface charge. So based upon the development of the positive surface charge, any negative surface charge molecule can be removed with the help of the modification of this guar gum. So why it is happened at this in the range of pH, this developed the particular guar gum, which is mainly consisting of this carboxyl group and as well as the hydroxyl group at a lower pH, this hydroxyl as well as the carboxyl will be get protonated surface on this particular guar gum. But when you are increasing the pH, that hydrogen ions will be started to remove from after 3.2 pH and expose the negative surface charge. That's why after the 3.5 pH, you can observe that a negative surface charge in this pure in this in the pH from ranges from the 3 to 7. At the same time, after it modifies that, the ammonium ions will not allow to crosses the isoelectric point, or it crosses this shifting of this negative positive surface and negative surface charge. So because of the development or the interaction of the ammonium ions, the particle or the guar gum which is exposing higher positive charge, which is mainly used, we can use it for the removal of negative surface charge material. It might be bacteria, it might be algae, it might be fungi. If you want to remove that, we can use this negative surface charge, sorry, positive surface charge guar gum material. Again, in the study you can observe that we can observe that how a lead material will be removed with the help of the guar gum product. So please, sir, please, anyone, I think someone is unmute. Please mute, sir. Someone is unmute. Please unmute, sir. Yeah,
Clear,
someone is there. Someone is, please. So from the schematic representation, we can observe that here they are using this guargum. In the previous result, I explained that with respect to the pH of the condition, the guargum will be exposed as a negative surface charge. So because of the exposing of the negative surface charge on this biopolymer, we can able to remove this lead ion. Why? Because lead is having the oxidation state of 2 plus. So this cationic species will be interacted. So to enhance the interactions, they are tested with the help of two material. One, they are using the kaolin polymer clay material, and other thing is here they are using the polymeric material. This kaolin material, this kaolin material, sir, please. There's someone of, sir,
our
please.
course ಮಾಡ್ಕೊಂಡು ಇಲ್ಲ ಕಡಿಕ್ ಬಿಗ್ ಡೇಟಾ ಸೈನ್ಸ್ ಡೇಟಾ ಅವು ಕೋರ್ಸ್ ಮಾಡೋದು ಅವು ಭಾರಿ ಇದೆ.
Someone is talking, please.
ಏನ್
Someone is talking. Someone is talking, please.
2 ವರ್ಷ
Unmute.
ಆತನ
Please mute, sir. Please mute, sir.
ಅಲ್ಲ ಇದು ಏನದು ಮ್ಯಾಥ್ಸ್ 2 ವರ್ಷ ಕೈ ಕೊಡ್ತಾನೆ.
Sir, someone is talking. Please mute this. Okay. We can observe that but by using this grafting method, those methods I will discuss later. So with the zeta potential curve, we can clearly stated that this particular chitosan will be helpful for the removal of negative charge species. Why? Because the zeta potential clearly stated that that amine group, the amine group which is present on the chitosan exposes a positive surface charge there. And there are two types of chitosans are there. One is the water soluble chitosan and other one is the water insoluble chitosan. So this sulfate soluble chitosan is generally present at the pH, at lower pH, which exposes the positive surface charge with the help of this amine group. When we are coming to this another insoluble chitosan, which is present and the pH from 3 to 7, it is also, we can observe that it is also comprised with ammonium functional group and another compound which is catechol. In the presence of oxygen, we know that the cation having the property to get or converted to the follow the beta of actually beta fatty acid oxidation model, and it exposes a carboxyl groups. So in the presence of oxygen. So here, once if you're talking about this insoluble chitosan, the major functional group like amine and the carboxyl group will be responsible for the interaction of the positive charged species. Here in the soluble species, we can interact the negative surface ions and nefarious surface particle, and in the soluble species, we can be able to interact the positive surface charge particles. So this particular chitosan can be used on both these pH conditions, both pH conditions. But very big drawback is we can use it at lower temperatures. Why? Because the stability is very less, and also it is highly insoluble in water. So because of the reasons, these chitosanes will be modified or grafted by different ways that we will discuss that later. And what are the, you can see that from this reaction, we can observe that at less than 6 pH, the chitosan will exposes a positive surface charge with the help of this amine group, first one is. And this chitosan can able to interact this negative surface charged particles in this hydrophilic end, sorry, hydrophobic end. If you see this micelles formations, so after it is interacted, then the flocculent polymer will be interacted with this. So the suspended particles can be interacted. You see this here, it is a positive charge chitosan, and here we are having this negative surface charge. So it can be neutralize the charges, and this flocculation takes place there. And another kind of this same material, we can use it for the removal of metal. Once if you added this metal ions, according to the charge, it will be the hot hydrated molecule or the water molecule will be interacted with this metallic ions. So because of the reason, you can observe that these two water molecules and this hydroxyl and the amine group will be satisfied along with metal ions, and it makes a complexation, follows a complexation process, and it will be get removed chemically. And at some time, this chitosan can be used on the membrane surface, coated on the membrane surface. That is, we can say it a cationic membrane. So in this, we can able to remove this kind of negative surface charge bacteria, fungi, or whatever it is. These are all the bacteria, fungi, yeast, and all the negative surface charge particle that will be interacted during the time of interaction. Sometimes the surface, the bacteria can be also what killed, and it will be separated. Okay, and so I told that some of the disadvantage of the chitosanes, which is having a very less mechanical property and also very less soluble in water, and also it works at very less temperatures. So to overcome all issues, there are different types of grafting methods are there. So based upon this acylation, alkylation, hydroxyalkylation process, carboxyalkylation process, quaternization process, carboxyalkylation process, thiolation process, phosphorylation process, graft polymerization process, we can enhance the mechanical stability of the chitosane, and also we can increases the functional group, which is mainly used for the different kinds of waste materials. So there are so many types are there. It is very difficult to explain within a 1 hour. Why? Because more than 100 models are there to grafting this chitosanes for the different purpose, for this medicinal purpose, for the wastewater treatment. There are different crafting methods are there. And for one example, I want to explain in this. This is the one kind of quaternization of chitosan by using this grafting polymerization process. In this process, the chitosan will be interacted with the one hydrogen molecule which is present on here will be replaced by using this free radical. And with the help of this free radical, you can make a unstable molecule of this chitosan, which is having a free ions here, free electrons here. Then with the help of adding this ammonium salt and this is quaternary ammonium methyl salt. So based upon this additions, we can develop a positive surface charge molecules. So based upon this positive surface charge, once if we develop, we want to make a huge amount of a positive surface charge molecule in the solution. Because of the reason, it will be coated on a negative surface charge molecule. This iron oxide is helping there. Once if you iron oxide nanoparticles will be used for to holding this all this kind of amine molecules. After that, it exposes a positive surface charge. When you are trying to interact the di molecules, which is having a negative surface charge, it directly interacts on the surface and try to make the flux, and it tries to absorb that, and it try to comes down there. So this is, and finally we can get this a clear solution. So there are different grafting methods are there for this development of a chitosan. This is also one kind of example there. And another one natural materials we can use for the flocculating agent, that is the starch. Generally, we know that the starch is consisting of two different components. One is amylose and another one is the amylopectin. Amylose, which is in the range of 25%, and the amylopectin, which is in the range of the remaining percentage. And the amylopectin, which is having the 1,6 linkages, and the and this 1,4 linkages, which is consisting of what amylase. When you are, if you want to if you want to modify this particular starch, we can modify it by the positively charged group of ammonium, sulfonium, and phosphonium group to develop the cationic polymers, cationic starch polymers for the removal of this negatively surface charged waste materials. And also we can effectively develop this cationic surface charged flocculant with the help of the quaternary ammonium compound. So here in the study, they used this researcher has used a cationic monomer, which is N3-chloro-2-hydroxypropyl trimethyl ammonium chloride. This is the general mechanism which is mainly involved here. So from that development of the cationic starch, we can able to reduce the turbidity of that particular wastewater, and also we can remove the cationic metal species which is present in this wastewater. These are all the major advantage when we are using this cationic things. So this is the one kind of another study which will be carried out with the help of the carboxymethyl starch grafted by the aminomethyl polyacrylamide. Here we can, with the help of this particular synthesis material, we can use to reduce the turbidity of the water, and also we can try to reduce the removal of the bacteria which is present on the liquid sample. So these are all the different types of biomaterial we can use for this flocculation as well as this coagulation effect. And another one is cellulosic material. We know that the cellulose is also a polysaccharide, which is mainly consisting of a carboxyl, hydroxyl groups on the surface. And we can say that when it is modified with this polyacrylamide molecules, whatever the functional group which is present on the surface, right, OH group, when the hydrogen is getting released or removed, all these modified polyacrylamide will be connected on the surface and exposes the surface charge for the removal of what? This wastewater. So from this graph, we can observe that one is the kaolin material, which is using as a coagulant, and the other one is which we are using about this. This is bamboo cellulose polyacrylamide with grafted polymer. You can see that up to the 4 pH, you can see that it exposes a strong positive surface charge. After the 4 pH, it exposes a negative surface charge. So it's clearly stated that before 4 pH, from the pH of 2 to 4, if you want to remove any negative surface charge species, we can remove that. Why? Because it exposes a cationic surface charge there. And once if you want to remove any negative surface charge material which is present in the wastewater, we can use it. Why? Because it exposes a negative surface charge material. So with this, I would like to conclude this talk. So based on this surface charge of the material, pH of the system, size of the material, and also because of based upon this affinity, we can improve the adsorption process as well as the settling rate of the contaminants. So based upon that, we can remove this wastewater. So whenever we are developing any material for this wastewater treatment, we have to be considered, or we have to functionalize based upon the development of the surface charge and how the pH will be behaved, how the material will be behaved with respect to the pH condition. What is the size of the material we are going to use in this? So these are the factors we have to be considered for this development of materials. Why we are particularly using biomaterials? It is very non-toxic and you can easily separate also. So with this, I will stop my talk. And if you have any queries, you please ask that. I'm ready to answer for this. Thanks for this.
Now the interaction session is open. Participants can ask the question to the speaker by raising your hand in chat box. Please, sir. Please raise your hands in the chat box, please. Anybody having doubts?
Yeah, it's audible.
Participants can ask the questions to the speaker now. You can raise your questions in the chat box. Please raise your hand.
Sir?
Tell me, sir. Tell me.
Okay, sir, continue. Sir is listening. You please